Hi, everyone. I'm Samuel. I'm from Portugal. I'm a computer science teacher. And I bring today a workshop. I like that you follow me and make the same thing that I'm gonna do. Um, we I will explain in this workshop how we can teach someone to programming and to construct 3D shapes. Uh, I don't know if you have an account in the Tinkercad, but it's easy because with the Google account you can register in a quick way. I don't know if you wanna follow me or not. Um, for create a 3D shape, we have a button in the right up corner, and we click, and you have the options code blocks. For example, if you want to make a cube, we just need to put this block in the middle, and in the right corner we have a play button. We click in the play button, the cube is created. In the code blocks, half of the cube is make down and the other half is up. Okay, we can change some things, some properties here. For example, the color. You can choose another color or the dimension. Let's choose it. Okay, this is the no name in English. This is the if you put 1 to 10, the shape are plane. No. Okay. If you put a number superior than 0, the it how you say it in English, the curve, not the, you don't are
Rounded.
yeah, they are rounded. Okay, is that? Thank you. Okay. Um, for example, if I want to make an house, a simple house with a cube in the a roof, we just need to put cylinder, not a cylinder, a cube. I have a cube, and now this way, 0, and now I can move for the cube don't have down of the ground. I have a block here to move, and I can move up, put the X, positive X. The cube have a 14 high. If I put 20 here, and now I click and play, and not in the X, in the Y. The Z. Okay, the Z. Okay. Now, it's not a good idea if I want to print this in a 3D printer because it don't touch in the ground. Okay, now it's okay. and with the roof, the move to have the same dimension, 40. If I touch play now, the roof is inside the box. I have to change the y, move the y. Okay. Oh, it's high. Happen here. That's the beginning. Okay. Now it's okay. Literal house. Um, the shapes can be rotated in these code blocks. I show how to create a shape, how to move, and how to rotate around the X or the Y or the Z axis.
Samuel, I have a question. Can you,
Yes.
I came in here a bit late, but what is the point of doing these programming blocks? What's the why? My question is why, when you can just,
Okay.
do without them.
We can use that for teach the kids to programming because they can use several things from the programming, the repeat, the variables, the
I see. So the learning objective that we're getting at is programming, and the vehicle that we're using is basically
and is
design.
more if you work with the uh, if you know the number of the dimensions, it's more precise than if we use only the hand to draw the shapes.
I wonder if you could get kids to make like animation sequences in this way.
We can save the sequence of the how we say.
The
This is
program.
a little video. When I do let me do another thing in the quick way. Everything about programming is there. The repeat, the if, the repeat until. I'm gonna do a rocket. I have a rocket now. I can show you.
I bet you
Okay.
kids love that. That's cool.
Okay. Do you see now? Yeah, I can export these as a gift. Where share, not share. Hey, yes, animate GIFs. What's happened? I have put the Z in 300 and the rocket go. Okay. Um, now you I don't know what you I have. It's better to do more shapes to demonstrate the other blocks. The rocket did what it was my last shape to do to demonstrate to you.
Can you
Um,
can you reset the camera view during the coding, or is the coding just about the objects that are on the work plane?
I don't understand at least.
So are there in some of the program, can you reset the view?
The view, no, not
Okay.
the view.
But the program itself, the animation as it were, will run no matter which, if you're looking at it from the top, the side, the back,
Yes,
the underside. Okay.
I can do that.
Yeah, so replay that one and show us from a different angle.
Okay, I can do in the top.
It kind of hits you.
Uh,
So how have
so
you used this with your students?
I have we have a graphic design course, and one of the things that they learn, they have a model about this tool about the code blocks. Um, I want to show you how to do a hole in the shape. Okay, I have a cube. Okay, and I have to do. I want to do a hole. No, let's show another thing like this. This one. It is how is it say in English? For the keys, you know,
Keychain.
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 The kids for draw these kind of objects, they have to think how many pieces of shapes they are there. The first one are a rectangle. And the text. Not the text. Sorry. For example, Codeblocks. Then the piece, the piece, pyramid, not the pyramid. Why are they a cone? Ah, it's a box. And how I can put the same dimension in the text and the letters, the text. I can use the x axis and the y axis. Okay, okay. Okay. The x and the x are the same than the text. Okay. They are too big. I can rescale. and I rescale the text, and the box automatically rescale. Change the color of the box to yellow, and put this Martin. Okay. Now the texts are greater than the box, and I want to have a distance in between the box, the limit of the box and the letters. I know that the letters have x-axis from the large or the weight. I can do that. Or and say 10. Okay, the text are in the middle of the box. Now I need something round here and here. I'm going to use a cylinder. And the radius of the cylinder is half of the large of the box. Yellow. And now half. Okay, I can add this one and the x, the x, the x. It's an x. Divide by 2. The cylinder is there. I want to put them that way, on this side. Then I have to move the cylinder at the left. How I know how much to the left? I can use the minimum of the x of the box. Minimum. Position. Minimum, not ID. The minimum of the x of the box.
I think that's the minimum X of the
No, it's the x.
cylinder.
The x. The x, not the x. Hmm. The x.
So you want to move the all the way
Left
across your
here.
box?
Here.
Yeah, I don't know. It doesn't really say what the x-axis
It's a
is
blue
in
one.
relation.
It's a blue one, not a purple one. Blue one. Where is the blue one? Okay, I create a variable. I understand now.
The variables.
Okay.
Ah, that's cool.
Mm. Now for the cylinder I have to put here too. Okay, now I have to do a hole here with another cylinder. And the color, we have to choose this color here. But is not the only thing we have to do. We have to group. When we group, we create the hole. Group one is yeah, the purple one. Where? Not there. Okay, I have to move first. And the minimum. Okay.
Yeah. So I was looking at the some of the templates or tutorials on Codeblocks, and I start to imagine lessons based on that. Just watching you, I can see there's a lot of math and programming, obviously.
Yeah.
But I also am like, well, I could do all that design without using Codeblocks, and it might be faster for me, right? Because I'm used to that. But but I was looking at this clock one, this clock tutorial,
Not know
and
what.
it's really cool. Let me share my screen with you.
Uh,
Oh, sorry, no, that's okay.
you can use that for the code blocks for make some GIFs,
Yeah, so this one,
animated GIF.
yeah, exactly. So they build the clock, and then the students, I guess, program the minute hand or the hour hand
Okay.
to go around. That's a pretty good lesson right there. That's hardcore math right there.
You want to share the
Yeah,
screen?
yeah, I'll share. Sorry. Replace current share. Let's see. Is this sharing? No. Okay.
Okay.
So watch this. This is pretty cool.
It's a rotation.
Yeah. But they build it
Oh.
from, this type of complicated design really lends itself to this code programming blocks, because they're putting all these markers exactly, spatially where they need to be. And that's just such a cool visualization of that. And then once they get the whole thing together, if I can fast forward through this, I think I can. Oh, I'm just putting the speed up. So this is what I'm talking about when
Yeah,
they,
it's cool.
yeah, that's a really cool project for a kid to do. And it really shows off, I think, these programming blocks in a way that I think is definitely a lot more.
You have to work about the many contents,
Yeah.
not only the programming, math, but other things.
Yeah. This is pretty good. This is a pretty good program right here.
You can do something like simulate a basketball, like a ball is jumping, or another things to throw up something for the physics teachers.
This
Because
one
I
was
think
pretty.
you can change the math.
I think this is really, like, I was playing this one before. This is crazy to me.
Ah. You have only 1, 2, 3, 4, 5 blocks. 6 blocks.
Yeah, exactly. But what it does is it just repeats the same. I could see kids just going crazy with this.
If you do this by your hand, you'll take more time.
Yeah, I couldn't do this. I couldn't do this. Oh, this is not something I could figure out.
Perfectly.
Yeah.
With programming in math is perfect.
And the other thing about Tinkercad is really when you drag on the work plane, you know, like you said before, it's not accurate. You're not dragging exactly 1 millimeter. It's all.
Yeah.
So this really makes these complicated designs work, I guess, in a way. That's really neat. And I think kids would love participating like that.
Even the physics teachers can use that for make an animated GIF for demonstrate some experience.
Yeah. Yeah. Neat. That's really neat.